So we are going to be learning to apply as logarithmic rules. So this is working from 5D from the Unit 3 and 4 methods textbook. So let's get started. So the first thing we need to know is the relationship between its logarithms and exponents. So if we know here that we've got log base a number, is equal to the exponent. So if we are wanting to rearrange this, um, we will have y is equal to our base to the power of x, which is our exponent. So that's the relationship. Now, one of the things I wanted to get us to think about is normally if we are timesing, we are adding the exponents. And if we are dividing, we are subtracting our exponents. So we're going to be using that relationship quite a bit. So here's just an example of if we've got log base 2, 8 is equal to 3, then that turns into 2 to the power of 3 is equal to 8. Okay, so let's have a look at this first question. So we're going to be looking at log a mn is equal to log a m plus log base a m. So we're just going to make them separate. So this is going to equal to x, and this one here is going to equal to y. We're going to divide them, and we're going to change to exponent form. So that means we've got a to the power of x equals m, a to the power of y equals to n. We're going to multiply both of these expressions. Now, if we do that, we've got mn together. Now we're going to use our index law by adding the exponents. Now, if we use our log, we've got log base a mn is equal to x plus y, which was our exponent. So this helps us see what we will be doing in that relationship. That if we are adding logs, then we are going to be timesing our m and n together. Likewise, I already talked about this before, but this is the relationship when we are dividing. So log base a m over n is equal to log base a m take away log base a n. So we're just going to separate them. So they are equal to x and one is equal to y. We are going to change it to exponent form. So we'll have base a to the power of xm and base a to the power of y is equal to n. We're going to divide both expressions. If we apply index law, this will be x take away y. Now I'm going to reverse it and go back to log form. So that is log base a mn is equal to the exponent, which is x minus y. Then we've got the power. Again, we're going to make log base a m is equal to x. We're going to define and change to exponent form. So we've got a to the power of x m. We're going to apply the exponent p to both sides. So we've got a to the power of x to the power of p is equal to m to the power of p. We will then simplify. So we're just getting rid of the brackets. We've got a to the power of xp is equal to m to the power of p. We will apply our log relationship. So here I've got log base a m to the power of p is equal to xp. Finally, we're going to substitute. So that gives me log base a m is equal to x. And if I substitute that in for x, I am going to get log base a m to the power of p equals p log a m. which is what we had up here. It's important that we see this and understand where it's all coming from because it's not just about applying these rules, it's understanding them. Then we've got our next one that we're going to go over, which is log base a m to the power of -1 is equal to negative log a to the power of m. Now, just this is going to be similar to what we did before, so I'm not going to go over this too much. I'm not going to, same with this, I'm not going to go over this too much because whenever we've got a to the power of 0, we already know it's going to be 1. So that's why we get log a 1 is equal to 0. Okay, let's go over a couple of these examples. So we've got log base e 81, take away log base e 3. So the first thing I'm going to do, we know it's take away, so we are dividing. So we've got log e 81 over 3. The next part is we can simplify that, so we will get log base e is 27. And then if we go over to the next one, we've got log base e ab, take away log base e a squared b squared. Well, we're taking away the bases the same, so we are just dividing. So we've got ab over a squared b squared. We can simplify this by cancelling out one of the ab's, and that leaves us with log base e 1 over ab. If we look at this next question, we've got 3 log base e x, take away 2 log base e y. First thing we're going to do is make it in an easier form. So that means I'm going to use the power rule. So this 2 is going to be grabbed out and put it over here. So it'll be base e y to the power of 2, and this will be base e x to the power of 3. Now I've done that, I can use my rule, and that is we're taking away. So I'm using the quotient rule, which is this divided by this. So that gives me log base e x cubed over y squared. Let's look at the next one. We've got log base e x plus 3, take away log base e x minus 3, and then take away log base e 2x. So this is where we are going to use this quotient rule. So I'll do the first two, and then I'm just going to write the next one with not a fraction. So that'll be x plus 3 over x minus 3 divided by 2x. I've done it like this because then this 2x, I need to think about the rule keep, change, flip. So divided by 2x will be times 1 over 2x, which is why the 2x is down here. I can't simplify it, so I will leave it in this form. Okay, next one, we've got log base e x squared minus 4x plus 10 is equal to 2 log base e x. So the first thing I'm going to look at is we are wanting to, I'm just trying to get the pen. We are wanting to get this side on the left looking similar to this side on the right. So I'm just going to grab this 2 and put it over here on the x. So that will give me log e x squared minus 4x plus 10 is equal to log e x squared. Because I've done that, that means straight away I know what is in this bracket is going to be equal to x squared. So then I am able to write an equation. The next part that I'm going to do is I'm wanting to solve for x. So that means I will take away x squared, and that leaves me with negative 4x plus 10 is equal to 0. I will then get the constant away, so take away 10, and then I'm going to divide by negative 4. That gives me x is equal to 10 over 4. If I look on the other side, we've got log base e 4x minus log base e 7 minus 3 over x is equal to 2. So the first thing I'm going to do is I'm just going to simplify it by using the quotient rule. So the quotient rule means I'm just going to go 4x is going to be divided by 7 minus 3x. The next part, what I'm going to do is again going to try and use my exponents, so the relationship, which means I will have base e to the power of 2 is equal to 4x over 7 minus 3x. I'm going to try now and get x by itself, so I'm going to times both sides by 7 minus 3x. I'm then going to expand, so this will be 7 times e squared and negative 3x e squared is equal to 4x. I'll get all my x's onto one side, so I have just added 3e squared x to both sides. Now I've got all my terms with x. I can grab the x and factor it out, and then I can divide everything by 4 plus 3e squared. So even though we're dealing with logs, we're just using our understanding of algebra.